Hello and welcome to today's daily Leetcode challenge. We'll be solving question 1877, minimize maximum pair sum in array. So, description. The pair sum of a pair AB is equal to A plus B. The maximum pair sum of the largest pair, the maximum pair sum is the largest pair sum in the list of pairs. Okay. For now, everything makes sense. For example, if we have pairs 1, 5, 2, 3, 4, 4, the maximum pair would be max of those three pairs. And the max of those three would be 8. Why? Well, because 4 plus 4 is 8, 2 plus 3 is 5, and 1 plus 5 is 6, the largest one of them being 8. Very clear. So essentially, we are finding the maximum pair from a list of pairs. Now, how do we find these pairs? Given an array of nums of even length, n, pair up the elements of n into n divided by 2 pairs such that each element of pairs has exactly one pair. Each element of nums is in exactly one pair, so meaning that each element at least has to be present, or it has to be present only once in a pair. And the maximum pair is minimized. Maximum pair is minimized. So if we are given a list of integers, the way to minimize the maximum pair, okay, interesting. So the way to minimize the maximum pair, so we have to, on average, reduce the value of a pair as much as possible. And to me, that sounds like adding the smallest possible value to the largest possible value. Let's see if that is roughly correct. In this example, if the array was sorted, we would have 2, 3, 3, 5. And the maximum pair of the minimal pairs here being 7 and 6 would be 7, right? The maximum pair would be 7. So I guess there are two steps to this problem, and it's crucial not to get mixed up in what those steps are. The first portion is identifying the pairs. And the pairs, the way that we identify them is we have to make sure that on average they are the smallest possible pairs. And what does on average here mean? Well, it just means that there's no outlier that is extremely large. So on average, that doesn't make sense. They all have to be equally small. That also doesn't make sense. How do I properly say this, given that the maximum, so this condition here is tripping me up a bit, and I'm not able to really put it in my own words. The maximum pair sum is minimized. Well, if the maximum pair sum is just the maximum pair that would appear given that we break everything apart into pairs. So the way to reduce that would be to have everything be equally small. This is just the feeling that I have. I don't really know how to voice it properly, but in my head, what I have to do is sum up the smallest possible value to the largest possible value, and then go on from both sides if the list was sorted. So actually, I'm going to do that quick and let's see what happens. I'm going to sort this array. I'm going to say that for I in range len nums divided by 2, I'm going to say that we have a small that is equal to I and a large that's equal to, let's say, nums I, nums len of nums minus 1 minus I. So we have the small value and the large value. And let's have a running max starting at 0, because do we have any numbers that are, nope, we don't have numbers that are negative. And let's say max is equal to max of max and small plus large. Return mx. See if this works. Ideally, it should. And if this does, this just proves that, okay, it does. Proves that the approach was correct. Ooh, that's not that good. But I'm still tripping up about how to properly convey this. If the maximum pair sum is minimized, all that means is I don't want there to be a pair that is... I want to minimize the sum of all the pairs. Does that make sense? I want to minimize all pairs as much as possible. Basically, if I had the numbers 1, 2, 3, 4, I could have pairs 1, 2, 3, 4. However, the maximum sum there would be 7, 3 plus 4. What I want here is the smallest possible sum. And so in that case, I would sum up 1 with 4 and 2 with 3. So I guess that's a better way to put it, and it makes more sense. However, I still don't have a concrete like voice explanation for how this should work. Let's see if there are any better solutions, because frankly 29th percentile isn't ideal. So they're still sorting. They're still saying that max is equal to, this is identical to what I have. What about this guy? Also, this is not faster. Whoa, so one-to-one solution, but well, logically speaking, it's one-to-one, but completely different results. Let's see why is this not good. I want to run this one more time just to see if there's a possibility of it just being faster, because it just wants to be. It's a little bit faster. Okay. Yeah, I don't know what's really going on. These seem to be these seem to be very similar in logic, so I'm just gonna leave this as is. Let me know if you like this solution, and yeah, thanks for watching. I'll see you later. Bye.